guys, welcome back. Mr. Medellin, Mr. M here, and today we're going to be covering grid errors. So again, on the principles textbook, it's on page number 233. It goes over all the different type of grid errors we can be exposed to that can happen. So what I'm going to do is my breakdown of exactly how grid errors occur. So I'm going to change this to black. All right. So grid errors are also known as grid cutoff. Alright, so we got grid cutoff. Alright, so grid cutoff, grid errors, there's different types of grid errors. So let's see, there's off focus grid error. Alright, number two, there's going to be off centered grid error. And there's different ways that you can word this. So off centered grid error, and then there's off level. Off level, okay, that should be a V right there. Number four, there's upside down grid errors. Believe it or not, I've seen this in the field. They're like, hey Robert, what's going on with my image? I'm like, oh, you shot it with your grid upside down. I'm like, oh, I didn't do it that way. And they just weren't thinking and they shot it upside down. All right, so we'll show you exactly how that's gonna look like. And then we'll also talk about the Moire grid error, or the Moire effect. So here, and I'm gonna put right next to this, guys, let's say CR systems. That's usually what it's going to happen with, all right, when it comes to grid error. So off focus is related to the focal range. So if you remember in a previous video, we said that there's a grid radius. Remember the line of convergence? And then the grid radius is the distance from where the beam diverges from, and it hits the grid. So the grid is designed to be used at a specific distance. So off focus has to do with a focal point error. So this here, this is where you have the wrong SID, all right, the wrong distance. So if your grid is designed to be used, let's say at 40 to 72 inches, and you're using it at 36 inches, well then you might end up with a grid error that's going to be known as off focus, all right. So off-centered grid error is where you have the body part not centered to the, or you can have the body part centered to the receptor, but the grid is off. So the lines, right? Remember the divergence of the X-ray beam are going to pull. They're going to pull on the object, but they're also, the lines of the photons themselves are going to be absorbed by the grid lines because it's not centered. These grids are specifically designed to be used at a certain distance and to be used at the center, right? The center point of the grid itself. So if your grid is not centered to the central ray, right? I'm going to draw it out for you guys here. How about that? So let's say here is your grid. Maybe I should have drew this first, all right? So this is a parallel grid. So if you're off-centered, what's going to happen here? You guys see how the X-ray photons are going to be absorbed by the lines of lead themselves? So you're going to end up with this loss of density and this uneven brightness on your image because the scatter is trying to produce your image versus the primary beam. You guys see that? So if you're off-centered, you can have a grid error. In one of the textbooks, I think it's Kettering, they say lateral decentering is another term for being off-centered. Lateral decentered means you're off the center. All right, so again, if you're off-level, this happens a lot, especially with the portable procedures. You guys remember those air mattresses? I remember shoving this in, the ICU or wherever, and the grid is off level now. So if the grid is off level or angled grid, so your grids are designed to be perpendicular to the central ray. But let's say your grid is at an angle now. So you're in that little divot, that little pocket of the air mattress, which we all hate, right? I never popped one, you guys, in all my years of taking x-rays with mobile units, but you put the grid underneath the patient, now the grid is at an angle. Well, if the beam was coming down this way here, you guys, take a look. What's going to happen? Again, your primary radiation is going to be attenuated by the lines of lead, and your scatter is going to produce your image. So your grid has to be perpendicular to the central ray. Upside down grid now, do you remember we said that focus grid? I'm going to draw here the focus grid. Remember, in the middle, you have these parallel lines. And as the lines go outward, they start to incline, correct? That was specifically designed to match the divergence of the X-ray beam. Watch this. There we go. Now we're upside down, right? So now the grid lines are going this way. All right, okay. So the grid would allow the primary beam to go through, but what's gonna happen here? What do you guys see? The grid lines, because they're going the opposite direction, they're gonna stop the primary radiation. And what's gonna create your image on the outside is the scatter, the low frequency X-rays. So upside down grid is the easiest to detect on a grid error, because why? On an image, you're only gonna have this black band of exposure going down the middle. That's how you know the grid was taken upside down, all right? So if you only get this exposure going down the middle, it's upside down. Now the last one here, you guys, and this is also included in the textbook. I think it's on the next page or so, but it's in chapter, what is this? Chapter 18 on the grids. The Moire. So a Moire pattern is a diagonal line pattern that occurs on the image. So back in the days, grids, we had this giant grid, and it was like a 17 by 17 grid, and we would use it for everything. And even if you put the receptor this way or that way, but the grid lines had to match the long axis of the grid. If you didn't do that, then the grid lines would be parallel to the CR reader when it was scanned. So I'm going to draw it out for you guys. So the Moire pattern are these diagonal lines that occur on the image because the grid lines themselves are causing an interruption in signal. So I'm going to draw it out here for you guys. So let's do this. If you guys are still working with CR readers, you put a cassette into the scanner. All right, so here's our CR reader. You put it into you put your PSP cassette into the reader, and if the grid lines, so let's say you took an X-ray, and let's say here, you guys, this is the grid lines, and this was your PSP here. If you were to go ahead and put this exposed PSP into the reader, I'm going to draw two separate colors here. I'm going to use green. So let's say these are the grid lines now that you're going to end up with on the image. When the laser is scanning, it's a red laser. The laser is going to be parallel to the grid lines. So that's going to cause an interruption of signal. You're not going to end up with the Nyquist theorem. So you're going to get this sampling error where you're going to have this interruption of signal. You're going to be missing segments of X-ray signal. And it's going to produce the Moire pattern on your image. And you're going to end up with these diagonal line patterns. So I'm going to write it on the board. So if your grid lines are parallel to the CR reader as it's being scanned, right, you're going to end up with the Moire pattern. Now this is more common with CR systems. Most systems now out there are going to be DR, so that's a separate issue. But when it comes to the Moire pattern, again, if the grid lines are parallel to the reader, we're going to end up with the Moire pattern, and you're going to have an image that's going to have these wavy diagonal lines going across your anatomy, and that's known as the Moire pattern. Okay. I don't know if you guys ever seen at the fair or at the pier, you see these shirts and it says 1 tequila, 2 tequila, 3 tequila floor. You guys ever seen those shirts? And the letters start to get blurry, right? You get these diagonal wavy lines. That's the Moire pattern that they're using. All right. So those are your grid errors, and I'm hoping that this helps you. Again, I'll go back to this one here. I'll do a quick rundown. Off focus is you have the wrong SID. There's going to be an indication of the focal range that's indicated on the grid. It'll tell you what you can use as your SID. All right. Off-centered, you don't have your grid centered to your central ray. Off-level or off-angle, this is where the grid is angled. It's not supposed to be angled. It has to be perpendicular to the central ray. Upside-down grid, we said that's more going to be related to focus grids. And then we have the Moire pattern. All right. So again, this is just a quick breakdown of grid errors and grid cutoff. I'm hoping that it helps you, and I'm hoping that this will help you understand the material and reach whatever goal that you guys have, whether it's for short term in class or for your ART exam. Okay? Thank you.